Okay. So cast iron is not recommended for the lever as a material, or brittle materials are not recommended for the lever. Then it is depend upon the cross section of that lever which you are going to decide that what factor of safety. Now here just we can say the application will decide, because already I have told you that application will decide the material of that lever. Now when the example is given by the dustbin, in that dustbin, when we are going to consider the material at that time, just we are going to see the all parts of the dustbins are manufactured from the plastic. So likewise duty also, that is where you are going to implement, where you are going to use that lever, is going to decide the material. But in the most of the cases where the levers are designed and they are applied, that is nothing but in case of safety valves of the boiler or braking system of automobile, which we are going to see in the daily life, the examples which we are going to see. In that case, the material is of ferrous material rather than the plastic and all that material. We are going to see. So in that case, the brittle material is avoided, and that particular application is also going to decide what the factor of safety you are going to decide for that lever. Now, normal factor of safety range is from 2 to 3 of that yield strength of that material is recommended for the safety valve. Okay. Now here you can see most of the cases we are going to use the aluminum alloy for the application of that lever. Okay, are generally used for the lever, and for some people are joining right now. Okay, and for the corrosive conditions, these alloy of steels are used. That corrosive conditions are nothing but where these levers are used, such as in case of marine application, for building of ship, or in case of ship, if somewhere the levers are required to be designed, levers are required to use. And in that case, in such applications where the corrosive conditions are more, then alloy steel is recommended for the application. This aluminum alloy and all that, they are recommended for the boiler application, where the levers are used for the safety valves, various safety valves of the boiler. Whereas in the marine application, we are going to recommend the steel alloy for the safety valve. Okay, and also the suitable heat treatment has to be conducted. That is nothing but this heat treatment, that is nothing but case hardening. Mostly we are going for the case hardening of that lever, so that the upper layer will become tough and in between it is soft as compared to the cast iron or brittle materials. Okay, this heat treatment, or the material on which you are going to do heat treatment, that materials are more preferable. Okay, so basically for the most of the applications, heat treatment is recommended. Okay, also in case of uh, automobile application, this most of the times the levers are undergoing for the shock. That is nothing but sudden load is applied. For example, when we are going to apply the braking system, at that time various levers are getting operated in that braking system. No doubt that if you are going to use this servo braking system, that is nothing but the pneumatic braking system or hydraulic braking system, or nowadays we are going to use these disc brakes. All these technologies, though the technology or ABS, that is and T-lock braking system. In that case also, these levers are used, because basically the foot operated pedal is nothing but the lever which you are going to use in braking system. So that lever, where it is undergoing for the various type of shock, that is nothing but uh, fluctuating load. So load which gets fluctuate. What the fluctuating load and all that, that we are going to see in the next unit. But on how you are going to design that any component under the application of fluctuating load, that we are going to see in the next unit. But where these levers are coming across the shock and wear. At that time, these alloy steels are more preferable for the as a material of that lever. Okay. Then factor of safety which you are going to consider, already I have told you that that varies from 2 to 3 of the yield strength of that material. Okay. Then in critical applications, like in case of boiler, this factor of safety may be increased. Okay. Or we have to take care that the factor of safety will be more for the critical applications. For in case of boiler, because boiler is treated as a what you can say bomb, where the pressurized steam is stored in limited area, and that pressure is also high for that boiler. That's why already I think in thermodynamics you might have learned what the our total boiler, what are the mountings and accessories of that boiler. In that, we are going to see this safety valve is accessory or mounting. Is it accessory or mounting? Hello? Have you learned it? Vaibhav Bhosle.
Yes, sir.
Okay. Thermodynamics मध्ये झाले boiler mountings and accessories.
Yes, sir.
Okay. Then can you tell me what the safety wall or under which category the safety walls are coming? Whether they are mountings or they are accessories?
Accessories, sir.
Accessories. Okay. They are not coming under the category of mounting.
Maybe.
Maybe. Who can tell me what is the difference between mounting and accessory? Dhotre. Saurabh Dhotre. Hello, Saurabh. Are you there? Hello. Madan Dixit. Nine. Manthan Dixit.
Yes, sir.
Can you tell me what is the difference between accessories and mounting?
सर ॲसेसरीज ह्या वरून लावतात
बर आणि
आणि म्हणजे जे सोबत येतं ना म्हणजे
हा
जे रिक्वायरमेंट असते ना पहिल्यापासून त्या ह्याची
रिक्वायरमेंट राईट रिक्वायरमेंट इज मोस्ट इम्पॉर्टंट वर्ड ओके ठीक आहे अजून त्याला आपण माउंटिंग म्हणतो ओके ठीक एकदम बेसिक लेवल इफ आय एम गोइंग टू टेल यू एकदम बॉटम लेवलने जर आपण म्हणायचं म्हटलं तर ज्याच्याशिवाय बॉयलर चालूच होत नाही त्या आहेत माउंटिंग आणि ज्याच्यामुळे बॉयलरची इफिशियन्सी वाढवली जाते किंवा त्या ऍप्लिकेशनची इफिशियन्सी वाढवली जाते ते आहेत माउंटिंग ओके ज्याच्याशिवाय बॉयलर चालूच होणार नाही दॅट इज ॲसेसरीज ओके and steam stop valve and safety valves. These are the accessories of the boiler. म्हणजे ज्याच्याशिवाय बॉयलर चालू करायला बॉयलर इन्स्पेक्टर सर्टिफिकेट देत नाही किंवा रिकमेंड करत नाही बॉयलर सर्टिफिकेट किंवा बॉयलर इन्स्पेक्टर दॅट इज नथिंग बट इट इज अ गव्हर्नमेंट ऑथराइज्ड पर्सन लाईक यू कॅन से लॉयर okay he is going to inspect that boiler he is going to check all the parameters of that boiler and then afterwards he is going to give certificate that yes you can run this boiler for these many days after that again you have to go for the maintenance again you have to take the recommendation letter from that boiler inspector okay and this exam or this license can get by only mechanical engineers no other can have such type of license that is what the informative information I can say okay for you म्हणजे बॉयलर इन्स्पेक्टर ही जी पदवी आहे त्याला 3 पेपर द्यावे लागतात त्या पेपर दिल्यानंतर त्यांना सर्टिफिकेट मिळतं ते सर्टिफिकेट मेकॅनिकल इंजिनियर शिवाय कुणालाही मिळत नाही आणि ते सर्टिफिकेट म्हणजे कुठल्याही Now we are surrounded by the sugarcane factories, okay, or sugar factories. So all the boilers which are there in sugar factories, they can only run when they are getting certificate from the boiler inspector. Okay. त्या बॉयलर इन्स्पेक्टर मध्ये तो सेफ्टी हॉल चेक करतो, वेदर ही इज गोइंग टू ऑपरेट और दॅट हॉल इज गोइंग टू ऑपरेट or not. He is going to check all the mountings, he is going to check, and then afterwards he is going to give the recommendation for starting of that boiler. त्यामुळे safety halls are coming under the category of mountings, and other, that is preheater, then water heater, then all other devices which you are going to mount on the boiler, they are coming in the category of mountings. Okay, त्यामुळे steam stop hall and safety hall, it is a accessory of that boiler. हे steam stop hall किंवा safety halls हे जे आहेत, that is nothing but the critical application of lever, and that critical application requires more amount of factor of safety, and that is decided by the designer. It is recommended by the designer. Okay, so this is what in exam you can have one that is descriptive type question, that is explain materials and factor of safety which we can use in lever. Okay, or write a short note on lever materials and factor of safety of lever. ह्याच्यासाठी तुम्ही हे 4 पॉइंट लिहून घ्या, or you can write that is the material which is used, aluminum alloy, steel alloy, then conditions where the materials are considered, that is nothing but corrosive conditions, then heat treatment which we can do on the materials, and second, factor of safety. Normal range of factor of safety is 2 to 3, but in the critical applications you can explain the application, that is nothing but boiler, or you can explain the application like levers which are used in the braking system of automobile, and you can write what the factor of safety or use of that lever, where it is used, whether it is critical application or not, and you can describe it for the 4 marks. Okay, next we are going to see, just we have talk about the design of foot levers. Now these foot levers are only differed by considering the force which we can operate or apply on that lever. In case of hand operated levers, this force is limited, okay, up to 500 Newton. That is 3 to 500 Newton. We can apply force with the help of hand, okay, on the lever while we are operating that lever. Whereas when you are going to design foot operated lever, otherwise all the procedure is going to remain same. When you are going to use bell crank lever, which we can operate with the hand, that is hand operated levers, and same way if you are going to design a bell crank lever which we can operate with the foot, then only different thing is that the force which we can apply with the help of hand and with the help of foot. Okay, so that point you have to consider while we are going to design the foot operated levers. Okay, and the force which we are going to consider which is exerted on the lever is 600 Newton to 800 Newton. A common single person can apply that much force with the help of foot, and that by considering that force you can further design the foot operated levers for the various applications where they are required. Now when we are going to see the problem, actual problem, in that problem statement, though it is written that the foot operated lever, they are going to give us how much load we have to consider for that particular lever. Okay, and if it is not given, basically it will not happen, because in case of our exam we are going to have the well-defined problems where we don't have to assume more data. Okay, but if it is not mentioned in that problem, then for the foot operated lever you have to consider the force which we can exert in between 600 to 800. Okay, and clearly you have to mention that considering the force which we can apply on foot lever as a 750, if you are going to consider it. I'll repeat it. प्रॉब्लेम मध्ये, एक्झाम मध्ये जे प्रॉब्लेम येतात त्या प्रॉब्लेम मध्ये आपल्याला हे अज्युम करायला खूप कमी डाटा लागतो. इट इज अ वेल डिफाईन्ड स्टेटमेंट. खूप चांगलं स्टेटमेंट असते, त्याच्यामध्ये सगळ्या क्वांटिटीज दिलेल्या असतात आपल्याला. ओके, तरी पण इन सम प्रॉब्लेम्स that quantities are not given, and if it is only written that design a foot operated lever, मग फूट ऑपरेटेड लिव्हर जर आपण डिझाईन करायचे असेल तर त्या प्रॉब्लेम मध्ये यू हॅव टू अज्युम द फोर्स विच यू कॅन एक्झर्ट ऑन दॅट फूट ऑपरेटेड लिव्हर. त्या केसमध्ये तुम्ही त्या प्रॉब्लेम सोडवताना वरती क्लिअर मेन्शन करायचं अज्युमिंग किती 700 600 इन बिटवीन 600 ते 800. ओके, assuming that much force, Newton force, which is exerted by single person. आणि त्याच्यानंतर मग पुढची कॅल्क्युलेशन तुम्ही करू शकता. ओके, कॅल्क्युलेशन सेम आहेत ॲज वी हॅव सीन इन केस ऑफ हँड ऑपरेटेड लिव्हर किंवा लिव्हरचं जे डिझाईन आहे त्या डिझाईनचे प्रोसिजर आणि फॉर्म्युले सेम असणार आहे. ओके, अप टिल नाव डू यू हॅव एनी डाऊट? एनीबडी ऑफ यू? हॅलो, I think it is going to become one-way lecture, and I'm not going to get any feedback whether you are getting it or not. After completion of lecture, I'm going to receive the phone calls that this is what, this is that. So you should involve yourself in the lecture. Sumit Patwari.
Yes, sir.
Do you have any question up till now?
No, sir.
No. वेळ लागला तर लागू दे. Take your own time for the understanding. Okay, but you clear your doubt so that we can go further. We can solve the problems, and you will get the concept of that point. Any question? Shall we move further?
Yes, sir. Yes.
Okay. Now this bell crank lever, this is problem on bell crank lever that we will see after some time. Before that, we'll see design of lever for the safety valves. As right now, I have told you that most of the application in boiler, these levers are designed for the safety valves. Okay, now you know that there are two types of safety valves which we are going to use in boiler, and that are spring loaded and dead weight loaded. Now the safety valve which you are going to see here is coming under the category of dead weight type safety valve. Am I right? Hello? Dhoniram? Hello? Hello?
Yes, sir.
Can you see screen?
Yes, sir.
Okay, which type of safety valve it is? Hello? Aftab Sheikh?
Yes, sir.
In this diagram, you tell me where the fulcrum is. There are 3 points, A, B, and C. Where the fulcrum is? At point A, at point C, at point B.
हे पशी
A हे जवळ फलक्रम आहे. ओके, म्हणजे फलक्रम हा एफर्ट आणि अप्लाइड लोड ह्याच्या मध्ये नाहीये. ओके, तो एका साईडला आहे फलक्रम. ठीक आहे. ह्या स्टीम स्टॉक फॉल कुठल्या कॅटेगरीत येतो? डेड वेट टाइप और स्प्रिंग लोडेड? हॅलो, if we are going to apply this load here, what is going to happen? Because of this applied load, force is generated here. This we can call as a P, whereas this is W. जर मी इथं स्प्रिंग जोडली असती तर तो कुठल्या टाईपचा वॉल झाला असता?
Spring loaded.
स्प्रिंग लोडेड इन्स्टेड ऑफ लोड, इन्स्टेड ऑफ दिस डेड वेट. हे जर नसतं आणि स्प्रिंग इथं जोडली असती तर दॅट विल बिकम स्प्रिंग लोडेड सेफ्टी वॉल. Am I right?
Yes,
And
sir.
yeah, as we are going to use this dead weight here, that is called a dead weight type safety wall. Okay, these are the two types where we are going to design that type of safety wall. Okay, and this type of problems will be there in exam paper. Now we'll see how this lever is designed in case of this dead weight type safety wall. First of all, we have to consider that in which direction the forces are applied. Okay, because this type of safety walls are used to close the opening of steam from the boiler. So the steam pressure will be applied in the upward direction in this case. Hence the total W which will be there, that will be applied in upward direction, and this dead weight, that is effort, are applied in the downward direction. Okay, if you are capable to calculate these two forces, then you can calculate the reaction which is coming on this fulcrum and its direction. And once you are able to calculate these forces, then further procedure is easy. That is nothing but just you have to consider whatever will be the cross section area which you are going to consider for that lever, and then afterwards you have to calculate the dimensions of that lever arm, and you have to calculate the dimensions of this pin as well as the bush which you are going to use in that pin. Okay, so it is very easy. Problems are easy, just like we have seen in case of knuckle joint and quarter joint. These problems are also easy, and that we can solve easily. So if you are going to see the problem statement related to the safety walls, most of the problems are related to the safety wall in this point. Okay, that's why first of all we'll take the problem related to the safety wall. A problem in problem statement, it has been written, I'll read for you, that a lever loaded safety wall. Okay, this is lever loaded, that is nothing but lever is used. Dead weight type safety wall, it has not mentioned, but it is a dead weight type safety wall. A lever loaded safety wall of 70 millimeter. Now, this 70 millimeter dimension is given, diameter is required to flow off at a pressure of 1 megapascal. Okay. Next, design a lever of rectangular cross section B into 3 of B and pin at wall spindle. Distance between the weight and fulcrum is equal to 880 millimeter. Distance between weight and fulcrum is equal to 880 millimeter. Okay, distance between the fulcrum and the wall spindle is 80 millimeter. Now here we may get confused. This is the wall spindle. This is wall, actually wall. Now this distance is 80 millimeter. Okay. Tensile stresses is 70 megapascal. Okay, this data has given in the problem. Now, first of all, we have to take whatever may be given in the problem. Now, material they have not recommended, but the property of that material is given. That is tensile stress. Okay, that the limiting value of tensile stress. Now, let me ask one question: that whether it is design stress or it is the yield strain, design tensile strain or it is a yield strain. I'll repeat. या प्रॉब्लेम मध्ये जे 70 मेगापास्कल दिलेलं आहे ही डिझाईन स्ट्रेंथ आहे. हॅलो, स्क्रीन दिसत नाही का? आर यू एबल टू
नाही दिसत.
नाही दिसत. सांगा की तेच म्हणतो मी मध्ये. यू हॅव टू जस्ट टेल मी or not able to see the screen. Okay, to which point you have seen it? Whether you have seen the derivative type safety valve? Hello? At least are you able to hear me?
Yes, sir. Yes.
Yes, sir.
Okay, whether you have seen the derivative type safety valve?
No, sir.
Whether you have seen the problem statement?
Yes, sir. I have seen.
Okay. In this problem statement, my question is that the tensile stress is given as a 70 megapascal, whether it is design tensile stress or it is a yield tensile strain. प्रॉब्लेम सोडवत असताना आपण डिझाईन टेन्साइल स्ट्रेंथ यील्ड स्ट्रेंथ वरून कॅल्क्युलेट करतो बाय कन्सिडरिंग द फॅक्टर ऑफ सेफ्टी. ही जी दिलेली टेन्साइल स्ट्रेस आहे त्याची व्हॅल्यू whether we should take it as a design tensile stress or yield tensile stress. हा क्वेश्चन आतापर्यंत आपण 3-4 प्रॉब्लेम सोडवले. Design tensile
stress, sir.
Yes, Jaydev has given answer that design tensile stress. Okay, let me ask to Akash Mane. Hello, are you there, Akash Mane? Yes.
Yes.
Which strength we can consider it? Hello.
Yes, sir.
डिझाईन टेन्साइल स्ट्रेस का यील्ड टेन्साइल स्ट्रेस आहे? प्रॉब्लेम मध्ये कुठंच मेन्शन केलेलं नाही काय?
डिझाईन टेन्साइल स्ट्रेस.
डिझाईन टेन्साइल स्ट्रेस. बरं, बेसिक क्वेश्चन माझा की हे कसं काय ओळखलं? कारण प्रॉब्लेम जर स्टेटमेंट असं आलं आणि आपण जर उत्तर सोडवायला घेतलं, बघितलंय आपण की इट इज नॉट मेन्शन इन द प्रॉब्लेम दॅट दिस इज व्हॉट अँड दिस इज व्हॉट फॅक्टर ऑफ सेफ्टी अँड then how you have considered it as a design tensile stress? जर yield tensile strength असती तर क्लिअरली प्रॉब्लेम मध्ये मेन्शन केलं असतं. एम आय राईट?
Yes, sir.
In that case they might have given the factor of safety also. Okay, then afterwards we have to go for using that formulas by means of which we are going to calculate the design tensile stress Then design shear stress. Okay, tensile and compressive are considered as equal. If it is not mentioned in the problem, you consider it as equal. If it is mentioned in the problem, then you take the recommended values or given values. Okay, मी पुन्हा एकदा रिपीट करतो. असे प्रॉब्लेम स्टेटमेंट आहेत ज्याच्यामध्ये हे मेन्शन केलेलं नसतं की वेदर इट इज डिझाईन स्ट्रेस ऑर यील्ड स्ट्रेस. पण ज्या केसमध्ये वी आर गोइंग टू कन्सिडर द यील्ड स्ट्रेस, त्या प्रॉब्लेम स्टेटमेंटमध्ये मेन्शन केलं जातं की ही यील्ड टेन्साइल स्ट्रेस आहे आणि फॅक्टर ऑफ सेफ्टी तुम्ही एवढा घ्या. ओके, 5 यू कन्सिडर ॲज अ फॅक्टर ऑफ सेफ्टी ॲज अ 5, 2, 3, 1 जो असेल तो. ओके, देन वी हॅव टू गो फॉर द कॅल्क्युलेटिंग दॅट डिझाईन स्ट्रेस. आपण जे मागचे प्रॉब्लेम बघितले त्या प्रॉब्लेममध्ये डिझाईन टेन्साइल स्ट्रेस एका प्रॉब्लेममध्ये आपण कॅल्क्युलेट केली आणि बऱ्याच प्रॉब्लेममध्ये ती दिलेली आहे. ओके, दॅट इज द मेजर डिफरन्स. Also, the lengths are given from the fulcrum of applied load and applied effort. Okay, and most important thing is that the width of that cross section is also given and thickness of that cross section is also given. The दोन्हीचं relationship दिलेलं आहे. That is rectangular section we have to consider. Okay, and it has a lecture संपलंय आता म्हणून. Okay, so while we are going to solve this problem, at that time, first of all, we have to consider the given data. Length from the externally applied load is 80 millimeter of that fulcrum. Length of the effort which you are going to apply, that is P, you are going to consider as a 1 megapascal. That is the pressure of steam. Okay, then length of that efforts which we are going to apply is 880 millimeter. It is not megapascal, it is millimeter. Okay, and the force which you are going to apply, the pressure of blow of fall is 1 megapascal, and we have to calculate this effort which we are going to apply by means of considering the equation, and then afterwards diameter of that wall is given as a 70 millimeter. Now from this dimension and this pressure, can we calculate the force which will be exerted at point C? That is W you are going to consider. Okay. Okay, we'll stop here and we'll solve this problem tomorrow. Is it fine? Hello?
Okay, sir.
Okay.
Okay, sir.
Let me take the presentee and in details we'll solve this problem and we'll see what the procedure which we can implement for the solving of this problem.